Good morning, everyone, and welcome to today's webinar, Why Your Site is Slow, Performance Answers for Your Clients. Your speakers for today are Steve Persch, Agency and Community Engineer here at Pantheon, along with our guest speaker, Mark Drummond, Front-End Developer at Lullabot. Just a few housekeeping items to go over before we start. Please make sure you submit any questions you have during the presentation in the question window, or tweet them at GetPantheon. We will answer as many of the questions as we can during the Q&A portion of today's presentation. Also, this webinar will be recorded, and the recording will be made available to everyone next week. I'd now like to turn it over to Steve and Mark.
Thanks, Atusa. A little bit more about myself here. I'm Steve Persch, Agency and Community Engineer here at Pantheon. I come from a background of building Drupal and WordPress sites, both as a freelance developer and as a developer at various agencies. You can find me as Steve Vector on Twitter, GitHub, Drupal.org. A lot of my coding activities these days are on GitHub, working on Pantheon's various WordPress plugins and Drupal modules. You can also find me as Drupal Haikus on Twitter. And Mark, can you tell us a little bit more about yourself?
Sure. Hi, I'm Mark. I'm the one who doesn't look like Al Gore sent into the future. Steve does a very good Al Gore impression. If you should ask. Anyways, so I'm a front-end developer at Lullabot, and we work to make really great digital experiences. And a lot of times I get asked to help with making the websites run a little bit faster, and so because that's very important for creating a good experience. I contribute to Drupal. In Drupal 8, I helped to co-maintain the breakpoint and responsive image modules. And the last few months, I've been working with my fellow Lullabots to develop the Drupal AMP module and theme, which helps Drupal sites to use the new AMP format, which we'll be talking about later. You can find me on Twitter at Mark Drummond. That's Mark with a C. And you can find me on Drupal.org with the username mdrummond.
Well, thanks, Mark.
Take it away, Steve.
Yeah, today we're talking about making websites. A lot of developers get in situations where they're developing a site, working with a team of people. Everything is going well. The client is happy with the features that are getting developed. They're behaving as expected. The project gets closer and closer to launch, and then at the last minute you hear from your stakeholder, we've got a problem. The site is too slow. The website is slow. And sometimes this feedback comes really at that last minute, a week before, a day before launch, sometimes even the day of launch or after the site is launched. The client thinks, the site is great, it looks perfect, it does everything it's supposed to do, it's just fast, so can you, the web developers, now just make the site faster. Well, when this feedback comes at the last minute, it's really frustrating to hear. It's tough to take a fully complete site and just make it fast at the last minute, and yet that expectation sometimes is out there. So when talking about performance, I find it really helpful to think at a very high level about what a website does. It's tempting to get into the weeds of performance issues really quickly. Let's first step back and talk at a high level that a website is sending responses from a server over a network to be interpreted by a browser. This basic dynamic of what websites do has been the same for decades. We have our server side where Drupal or WordPress live. They're making the HTML, they're making the website, sending the website as HTML out over the internet. Browsers are then parsing that HTML and getting other assets as needed, images, JavaScript files, CSS. So today we'll be talking about key architectural points related to speed, and we'll be talking about them server side, network, and client side. With Mark here, we're going to spend most of the time focused on the network and client side, but I'll start us off with the server side. We'll also be talking about the underlying why. It's really tempting when dealing with performance to get into a checkbox mentality, making sure we have all the types of caching available. We've done every optimization that can be done. And it's easy to lose sight of the underlying why that makes some of these boxes difficult to check. So Again, at the really high level of what a website is doing, more abstractly, it's having a conversation with the client. That server is having a conversation with a browser, and conveniently, browsers can also be called clients. And I highlight this word client because we'll find that the conversations and interactions that we as web developers have with our clients end up manifesting themselves in surprising ways in the conversations our websites have with their clients, the browsers. So even more abstractly, what a website does is informs the world about an organization. And if the organization is some kind of store that's selling things, we'll find that the patterns that manifest themselves in the physical world, the checkout process, will also manifest themselves online. So for a store that's having a difficult time streamlining its checkout process in the physical world, there's a good chance that that process will also be slow and inefficient on the website itself. So jumping in now on the server side of things. We've gotten this problem reported from our stakeholders, from our client. The website is too slow. So starting on the server side, we can think, well, the server is not responding with HTML fast enough. Again, websites are taking in requests from their clients, and they're expected to give responses as fast as possible, usually in the form of HTML, sometimes JSON or some other format. So we have to ask ourselves, why is this HTML response not coming fast enough? Why can't we respond in a very small number of milliseconds? Well, the Web 1.0 answer to that question is that there's a limit to how fast .html files can be read off of a hard disk. 20 years later, this answer has shifted a little bit, but the basic expectation is the same, that when a request comes in from the internet, the server can respond with HTML within a very small number of milliseconds. So if our HTML response is not coming that fast, there's a good chance that our URL is not present in Varnish, or our reverse proxy cache. So let's talk about what Varnish or reverse proxy caches do in general. Varnish is just one type of reverse proxy cache. So these types of caches sit in between our server, where Drupal or WordPress lives, and the wider internet, where the clients or browsers live. So a browser sends in a request to our infrastructure saying, I would like the HTML for your homepage, or /about, your about page. Please give me that HTML. If Varnish has recently seen that request come in, if it 30 seconds ago saw someone else ask for the about page, then it doesn't have to go back to Drupal or WordPress and ask Drupal or WordPress to regenerate the entire about page HTML. That's a slow process no matter what. If Varnish has seen that request recently, it can immediately send that HTML right back out in a very small number of milliseconds. If Varnish hasn't seen that request come in, maybe it's a request for a page that isn't visited all that often. Maybe it's the WordPress post 123. If Varnish hasn't seen a request for post 123 come in recently, it does have to go and ask WordPress, generate all the HTML for post 123, give that back to me, and then I'll pass it along to the client and cache it for the next time someone asks for post 123. So if our HTML is not in Varnish, we again have to ask, why again? Why would this HTML response not be in Varnish? And the answer has to do with our HTTP headers. These are the pieces of metadata associated with HTML requests and responses. What we're looking at here is a debug tool that Pantheon provides for debugging Varnish itself. We're seeing the metadata for missionbicycle.com. So missionbicycle.com is responding with its HTML, and it's also providing metadata about the response. At the bottom of this screenshot here, we can see that the cache control header is set to public, max age equals 900 seconds. This piece of metadata is the way our server infrastructure communicates out to Varnish and anything in front of Varnish that this HTML response is publicly cacheable, meaning it can be given to anyone who asks for it, and it can be cached for 900 seconds or 15 minutes. If this cache control header were different, if it said private, or if it had a different max age, then we would have different caching rules, and Varnish may not be able to hold on to it as long. So over on the Drupal side of things, we have core settings that dictate these basic caching rules. And more advanced plugins can do even more granular caching rules. Drupal core out of the box gives you the ability to set the default number of minutes that something gets cached. So again, let's take a stab at this question of why is our site slow, our HTML response is not coming fast enough. Maybe we don't have any reverse proxy or CDN at all. Maybe Varnish simply isn't there. And maybe that's because we're running on a custom server infrastructure and our internal team doesn't have the expertise to set up Varnish. And we are in this situation because the internal politics of our organization says we can't host elsewhere. The key question here, I think, is at what number of sites is it cost effective for our web development team to manage Varnish config? If I were working alone as a single developer managing a single site, I wouldn't want to dedicate the time to learning all the details of Varnish. I personally don't know enough about Varnish to be responsible for all parts of its implementation. Pantheon as a whole, we're managing well over 100,000 websites. It's absolutely in our interest as an entire company to have Varnish expertise in-house. So somewhere between 1 and 100,000 sites, it does become cost-effective for this team to have that Varnish expertise. And I think this is one example of an even broader question. What decisions can a team make that will make the site faster and the team faster? One of the things I like about Pantheon is generally when sites get moved over to Pantheon, the sites themselves get faster because they get Varnish and all these other pieces baked in. And then the team managing the site no longer has to worry about managing those details directly themselves. So the site gets faster and the team's ability to complete work also gets faster. So sometimes we do get past Varnish. Varnish isn't going to have every single request cached. So we do have to get to Drupal or WordPress eventually. And Drupal or WordPress can respond slowly as well. And there are a million answers you can get to the question, why is Drupal or WordPress responding slowly? You've got too many files, you're running too many queries, or maybe slow queries. There's way too much memory getting used because we're possibly loading too many nodes or posts, and we're calling too many functions. Too many calls to the same function. And really what we need is the ability to introspect. Before trying to jump to conclusions about why our Drupal or WordPress site is responding slowly, we need to be able to look at some data that gives us a clearer picture. What we're looking at here is New Relic, which is just one tool available for introspecting the behavior of our server, finding out exactly which paths, exactly which functions are taking the slowest to execute, exactly what times of day does our site get slowest. And with this kind of data, we can then make more informed decisions about turning on internal caching layers, finding queries that can be optimized. But without this baseline of data, we're really powerless to make a site faster. So another more specific look at this problem of Drupal is responding slowly. Maybe we have too many modules, or we think we have too many modules. So first of all, can you have too many modules? Well, the Drush site audit tool will complain after 150 modules. I've certainly seen sites with 200, 300 modules installed. And that is a lot. And it will make a site bootstrap or initialize slower because every single module has to be loaded. That's more PHP files to load on every single request, more modules to ask about hook implementations, and the site will get slower. So it is a concern. However, I think it's a leading indicator about a deeper concern. So why would we have too many modules? There's a good chance that if we have 200 or 300 modules or plugins on a site, that some of them overlap or duplicate. So perhaps our team doesn't have a strong understanding of the history of a project. Maybe developers from our agencies rotate every couple months, and someone is coming onto a site that's been around for 3 years, and they only have 3 months worth of experience with that site. There's a good chance that in that situation, they'll add another plugin that does the same basic task. In Drupal, Panelizer module and Display Suite module can both take over view modes of your content. And it's unfortunately common that both of those will get installed and get used for the same purpose. So that does make a site just a little bit slower, but it's an indicator that the team doesn't have an awareness of history, isn't talking to one another, and we're going to find performance problems all over the site because of that. So can we treat slow like a bug? Do we have tests that tell us what we're supposed to be expecting from our set of modules? Can we look through our Git history and find out maybe when these duplicate modules were installed and find out the project management tickets associated with them? To what degree can we really treat this problem of slowness like a bug that's not meeting our expectations? You can define a bug as really an unmet expectation. So if our server is responding slowly, ultimately there's a good chance that slow was not defined up front, that we didn't have a clear expectation of what the performance characteristics of the site would be. And if we're having a hard time defining slow up front, there's also a good chance we're defining other things up front as well. User personas, acceptance criteria, testing strategies really should all be defined as early as possible in a project. So there are lots of aspects of a site that a development team has to be concerned about: security, accessibility, that the site is really behaving as expected, that we have some awareness of who's using it, and all of these questions have to be addressed throughout the life cycle of a project. It's unfortunately common for teams to think we can build the site to its specification, we can make it look right, and then in the last 2 weeks we'll take one sprint for performance, turn on all the layers of caching, and hope that the site is then fast. I don't think we would do that for security or accessibility. Just assume throughout the life cycle of a project that we're building something insecure or inaccessible, and we'll fix the security and accessibility problems in the last week or two. That's not a reasonable way to go about it. The more things can be defined up front, the more likely it is that your clients will be satisfied at launch. So I'm going to turn things over to Mark now, who's going to talk about the network and client side of things. Mark, you ready to take over?
I sure am.
Great.
All right. So, everything looking okay?
Looks like it, yes.
Yes.
Great.
Okay, great. Wonderful. All right, thanks, Steve. I think Steve did a great job of summing up a lot of the things that you should look at on the server about how your HTML page gets constructed and delivered to you to get to your browser. And that's really important. I'm here to also talk about all the things that happen after that. Because a lot of times when people think about, I want to make my site fast, they think about the server part. And it's usually just as important to think about the network and the client-side parts of how to make your website fast as well, because that can have as big or bigger of an impact than the server-side optimization. So we're going to start by talking about how your files actually get from the server to the browser and some things that we can do to make that better. So network, that's what we're talking about. So we talked about the HTML getting delivered, and doing that from Varnish is great. There's also a lot of other files that need to get delivered to make your website happen. There's CSS, there's JavaScript, there's images, there's font files, all kinds of important things that need to be delivered alongside of the HTML. And sometimes it's actually those that are slowing down your website. So why is your website slow? It might be that something's going wrong with how we're delivering everything else on the website. So, why is that? Well, for a long time, a rule has been for performance optimization that you need to look at the number of files that have been transferred, that are being transferred. If you have a whole bunch of CSS files and JavaScript files and image files, just the very existence of having a large number of files is a problem. And that's partially because you may be using the old standard for how we make connections between a server and a browser, and that's HTTP 1.1. And there's a new standard, HTTP 2, which is a mouthful, so I'm going to shorten it up to call it H2, which a lot of people have been shortening it to that. It's a handy way to save a few syllables. So H2 kind of changes that assumption that we've been making that the number of files is really what's the critical factor for how fast your website is. And so I'm going to talk a little bit about why that's the case. So with HTTP 1.1, you are making a connection between the server and the browser for every file that you're delivering, basically. There's some reuse of connections for certain situations, but a lot of times you're making a new connection between the server and the browser each time you deliver a file. And to do that, the browser and the server have to have a conversation. They have to say, "Hi, my name is browser. I'd like to get a file from you." And the server says, "Hi, my name is server." And they go, "Oh, great. How's the weather?" And then they kind of have a little conversation and get to know each other so that they know how fast they can transfer files. And there's a bit of a ramp-up time for that process. And so there's an overhead for every single file. With HTTP 2, H2, you only have one connection between the browser and the server. And then here's a fun word. The multiplexing takes care of putting together multiple files in each their own stream within this one connection. So there's only one conversation between the browser and the server where they introduce each other, and then everything's going over the same pipe. So there's still overhead for the amount of file size that you have, and if you really get to an absurd number of files, like 500 JavaScript files, well, you might run into a problem there, but you probably have some larger issues if you're delivering 500 JavaScript files between the server and the browser for one individual web page. That's a lot. So, but if you're in the range of a normal website, say between 20 and 100, something like that, H2 is going to be a big, big improvement in speed because you have less overhead. So why are assets taking too long? We've got each file with its own connection because we're not using H2. Well, why are we not using H2? One of the requirements of H2 is that you need to be using HTTPS. You need to have a secure security certificate for your server. If you go to a browser, you see that little lock icon. And that's becoming more and more important anyways, because search engines and browsers are sometimes putting up warnings if you don't have your site secured. It's a generally good idea to be using HTTPS, but that's been a barrier for people because it costs money and setting it up is not exactly easy. So that's been a problem. However, that has been getting easier. In the last year or so, the Mozilla Foundation has created this service, Let's Encrypt, that lets you get a free certificate, security certificate, so that you can have HTTPS on your site. And is it perfect for an enterprise website? Probably not. But if you have a small website and you want to take advantage of H2, and then getting a certificate this way is great. So how do you do that? So I use Pantheon for my personal website, markdorman.com, and I set this up for myself using Pantheon. There's an easy way to integrate a service called Cloudflare with Pantheon, and that allows you to just kind of click one button and bam, you have HTTPS. You have to do some things behind the scenes to check to make sure that everything's working, but generally it's a pretty straightforward process. And then you can have your website secure, and you can have H2, and it can be a big performance improvement. So that's kind of neat. And that kind of brings us to our next point, which is another important factor for delivering all these different assets between the server and the browser is using a CDN. So what is a CDN? So a CDN solves a problem, which is that the server is too far away from the browser. So you may not have gone to this webinar thinking that we'd be talking about Einstein's general relativity theory and coefficients of coaxial cables, but hey, here we are. So it matters whether if you are trying to send something from one side of the planet to the other side of the planet. You have one server, and it's on the other side of the planet, and you're here, wherever you are, and the file has to transfer from one location to the other. That takes time. Yes, it's traveling with electrons, but that's not instantaneous. The speed of light is a factor there. It takes time to send something completely around the world, and it also depends upon what sort of medium that data is traveling through. If you're going through a fiber optic cable, it can travel faster than if it's going through copper or coax cable, which slows down transmission of things. So basic thing is that if you've got your server really far away from the browser that's trying to get a file, it slows things down. And that is the problem that CDNs solve. So a CDN is a content delivery network, and it's essentially placing servers at multiple places around the globe so that a file request has less distance to travel physically. And that's essentially what there are. So there's lots of different CDNs out there. Akamai is one that's pretty well known. Cloudflare, the service that I mentioned that helped me get H2 running on my site, also provides a CDN, and there's a free level that you can use that I've found to be really easy to set up, and got that working on my personal site. But there's lots of other CDNs that are also fantastic, and if you have an enterprise site, you should probably work directly, to figure out how all that stuff works. But if you just want a simple thing to get started for a small site, hey, there's some neat free tools available to you. So those are a couple things that you want to think about. You want to think about the number of files that you have. If you have H1.1 running on your site, then you're going to want to potentially aggregate your number of files so that you have fewer files going over transmission. But if you have H2, you can get HTTPS and H2 running, then it's not that you don't have to totally worry about the number of files you're transmitting, but you can potentially solve a little bit of a performance bottleneck that way, and getting a CDN there will help. So that's the network side of things. So great, we've transmitted all these files, and now they are in your browser. Ta-da! Well, we're not quite done yet. The browser actually has to do a fair amount of work in order to turn all of those files into a web page that you're taking a look at. So you think, okay, well, I want to make that better. I want to optimize it. And somebody says to you, all right, well, first thing to do is to take a look at Chrome DevTools, or what other dev tools you prefer. Take a look at the Network tab. Take a look at some way that shows you how files are being delivered. And so you open it up and you see something that looks kind of like this. And it's maybe a little bit overwhelming, but you can start to sort of figure out, well, what are some things where things are going wrong? So this is actually the network tab for Drupal.org. And when you're logged in on the dashboard page. And you can see the first item there. The first item you're always going to see is pretty much the HTML page. And so you can see the size of it. It's 20 kilobytes, not too bad. The time is 954 milliseconds, and that's because it's content that's not very easy to cache because it's on an individual user basis. So that's potentially a bottleneck. But then you have a bunch of CSS files, and you have JavaScript files. You have some images in there. You can see that the waterfall is sort of angling off to the right because you only have a certain number of connections that are open at a given time, and so they have to sort of take turns. If you're using H2, that would help improve that by giving it more of a straight line down. And so, you might think, well, what I need to do is make the files smaller. That would help, having H2. This is a good place to start, but we need to understand a little bit more about how the browser actually works with all of these files. So basically your browser gets the HTML page, and it goes through and looks and finds all the CSS and the JavaScript files and the images and everything like that. And then it looks through the CSS, sees if there's any more files in there. And as it's finding files, it's sending off additional requests to the server. It says, hey, I need this, this is on the menu, I want this one, I want this one. And it gets them all in. And then it has to work out how to make a web page out of that. And we're going to talk about how that happens, because understanding that can help you improve the process so that your website loads more quickly. One of the things you might do is you might go to a website that gives you a whole bunch of different numbers, and so you look at these numbers and they tell you, oh, all right, well, here's this problem and that problem, and it can be kind of overwhelming, and you might try to just focus on the numbers and try to knock each of these down smaller and smaller. And what I'd suggest is that rather than just looking at the numbers, it helps if you can take a step back and understand what is a browser doing with all these files, how is it putting together a web page. Because once you understand that, then it becomes a little bit clearer how to make things better. All right, so we have the problem that our website is too slow. We're trying to figure out why is this. We have these numbers, we've looked at this waterfall, but we still don't completely understand. So why is it too slow? Well, the browser's taking too long to put all of this together into a web page. It's taking too long to paint the screen. And the reason is because we haven't optimized the order in which the browser is handling things. So now we get to learn about how a browser does that. How does it actually go through that process? So if you were to look at an optimized path for how a browser puts together a web page, you might see something like what's on top. Ideally, you'd want the web page, for somebody to feel like the website is loading quickly, you'd want as the browser gets parts of it ready, it'll appear on the screen. So parts of the web page load in bit by bit, and suddenly the whole web page is there after everything is done. That's great. People feel like, hey, things are moving along, and I feel like the web page is loading. What you want to avoid is that lower part where you haven't optimized anything and the browser is doing all of its thinking, and then suddenly the web page all pops in at once and you've had a blank screen the whole time. And people will just feel like nothing's happening and they'll move away from the website, and all the great work you've done on your website kind of goes to waste because people never see it. So we want to kind of break this process down and optimize a little bit more. So how do we do that? So let's take a look again at how this works. So we talked about, your browser requests HTML page from the server, it gets it, then it looks through the menu and it gets all the CSS and JavaScript. And so what is it doing? It's looking through that HTML, it's parsing that, and it's coming up with a DOM, a document object model. If you've worked with JavaScript, you've probably heard of the DOM. It's basically a map of how all the HTML interconnects with each other and documents, here's what's on this web page. And it actually, the browser has to do the same thing for CSS. It comes up with a CSS object model, and it's like, here's all the rules for CSS, and here's the selectors, and here's how they would apply. And then it puts those two things together, the DOM and the CSS. It runs all the CSS rules against the DOM and comes up with a render tree. And that way it knows for every part of the page, here's the styles that are applied to it. The tricky thing is that if you have JavaScript involved, JavaScript can change the DOM. It can, and it also can change the CSS as well. But the JavaScript can potentially change anything in there. So the browser knows if I have to deal with JavaScript, then I need to wait to make sure that I completely understand all the changes it might make before I really put together my render tree and I can start painting everything on the page. So one of the important things you want to think about is, how do I get JavaScript from blocking the browser from doing its work of putting things together? If you have JavaScript that is in the way, then from doing that, and it's not actually changing anything as the page is loading, then you might want to think about getting it out of the critical rendering path. So to do that, you can mark a script tag as async and defer. That tells the browser, hey, I don't really need to worry about that. So you've done the job of looking at that and you realize, no, we don't really need that until later on in the process when people are interacting with the website. So that's good. Another thing is putting your JavaScript at the bottom of the page rather than in the head section. If you really need that JavaScript to run right at the top because it's definitely going to affect how the browser needs to render that page, that's fine, do that. But if not, if it's not really needed until later, then put it at the bottom, and that will help speed things up. All right, so you've optimized that part, and you get the render tree built. So how does the website actually put this all together? And this matters because it matters not just how your web page loads, but how people interact with it afterwards. So the web page, it gets all the style rules, and then it figures out, how do I lay this out on the page? How does the layout of this work? And then once it has those two things figured out, it can start painting things on the screen. It can put little pixels where it needs to. And it also can figure out, hey, some things are on different layers from each other. So if you're working with z-index, or you're working with opacity or transform properties in CSS, those actually end up creating separate layers generally for how the browser interacts with each other. And that matters because if you want to change something on the screen later with an animation or some sort of JavaScript interaction, the later in that render process where you can make a change, the less impact it's going to have on how janky your website feels. So if you can change an animation with just opacity or a transform property in CSS, then it's pretty straightforward for the browser to just move around those layers on top of each other, rather than if you make other changes, you might have to repaint the entire screen or part of the screen, or it might have to recalculate the entire layout, which is pretty expensive and can make your website feel pretty janky. So the rule of thumb is that you want to change things as late in the process as possible. All right, so we've optimized that part of our website. We've got the rendering path that's working better. So what else is a problem? Well, we mentioned, the file size matters too. So maybe your CSS file is too big. And why is that? Well, you have a lot of CSS on your website. Okay, well, why do you have a lot of CSS? Well, maybe you have a lot of CSS that you're not actually using on your website or on the given page where things are being loaded. So this can be a real problem if you have too much CSS that's not even being used. So this can happen if you're using a CSS framework and it has tons of CSS rules that you might need, and it's loading the entire thing on every single page, but you're not actually using all of those rules. Well, that's a lot of potentially wasted CSS that the browser has to not only download, but like parse through and calculate against the DOM. So if you can trim that down and deliver only the CSS that you use, that's an improvement. But more than that, it's also not just, well, I'm delivering all the CSS I might use for every single page, but you might even just have some CSS that you just never used before. You've had the site running for a long time, and there's CSS that you wrote 5 years ago, and it's still there, and you're not sure, is this something that is needed or not? And so that can be a real problem. So you want to have some sort of system for how your CSS works rather than kind of a hodgepodge. Personally, I like using BEM, block element modifiers, what that stands for, and it basically means you use one class per thing on your website, and that helps prevent a lot of bloated CSS because, well, it varies based on the site you need, but you have one set of styles for each thing on your site, and it makes it easy to work with when you're on multiple team members because you can change one component's styles without breaking somebody else's styles, and so it's easy to confidently edit your website CSS and make changes. And if you have a lot of CSS that interacts with each other, it can be more difficult to do that. If you have a really large website with lots and lots of CSS components, that system might not end up working for you, but it's a good one to keep in mind. But once you have it kind of figured out, a good thing to do is visual regression testing. So if you set up tests and say, here's how all of the different pages on our website are supposed to look, you capture a known state of here's how it's supposed to look, then you can as you make edits to your CSS, you can see, has this changed or not? Wraith is a tool that can help you with this. And you can see, okay, well, if I change this, it's going to cause a problem, or nope, I can delete this bit of CSS and it won't be an issue. So yeah, so that's good. So if you can minimize the actual amount of CSS that you have on your site, that's good. And then you want to think about loading only the things you need for a particular page. So this is some Drupal code, and it's adding some JavaScript, and this is old. Drupal add.js is not a thing in Drupal 8, but it was in Drupal 7, and this is just adding it everywhere. It's adding globally, and it might not be something that you actually need everywhere. So in Drupal 8, there's this library system that lets you set up CSS and JavaScript libraries. You can define their dependencies. And so you say, if I need this file, I also need this other thing. This depends on JavaScript. So when the JavaScript that you wrote custom gets loaded, it also loads the dependency, like jQuery. So then you can say, all right, I'm going to only use this library at the place where it's used. And then Drupal can take care of only loading the bits that you actually need. So, so when you have a lot of CSS, and there's kind of a couple issues here. So if you are breaking this down more granularly and only delivering individual files, then each of them is cached separately. If you're using H1, that can be a problem because that can be a lot of separate HTTP requests. But it's really delivering only the things you actually need for a site. The alternative with H1 has generally been package all the CSS and JavaScript into one or two, as few as possible requests. And the challenge with that is that you don't generally get good caching because you're delivering everything you need for the entire site on every single page, and you might not actually need all of that for one given page. Drupal kind of splits the difference. It figures out, here's all the things that are needed globally, and then loads those in one aggregate, and then it comes up with separate aggregates for things that might not be needed every single time. You still can get a little bit of overlap with that, but it's a decent way of doing things. But if you can load things conditionally, that's really good, and especially in the world of H2, where it's not as expensive to do that, that's a great idea. One of the things you see a lot in Drupal themes is all the CSS is getting aggregated into one file using like grunt or gulp, and then the whole thing gets attached globally. And so one thing you might think about, especially if you're moving to H2, is putting smaller packages of CSS and JavaScript files that are used. If you have some stuff that is used globally, sure, pack that all up in one aggregate. But maybe think about moving parts off into a non-aggregate. So, all right, other things that can slow your page down are fonts. If you haven't optimized your font loading strategy, so we can't get into all the details of this here, but basically, if you reference a font file within your CSS file, that blocks the entire page render. So if you can offload that and load it separately and use fallback fonts initially and pull in your web fonts after they've loaded, that's a better strategy. You can go to zachleet.com and find some great articles about how to do that. That's a huge win. Responsive images are another issue. If you are delivering one image file that will work for all possible breakpoints, for all possible viewport sizes, you can be downloading a huge image that you don't need all that space for mobile. So use responsive images. Drupal has some great built-in tools for responsive images. So that's something you can do to speed things up. Another big challenge is that you have a lot of third-party widgets. This is something that's not always under your control. You might have people say, hey, we need to put all these trackers on. You have an advertising-driven website, and we need social sharing tools. And so there's all these JavaScript widgets that get used, and it's just too many, and it bogs down your site. And sometimes it feels like there's nothing you can do about it because it's somebody that's in the business office that has decided this is important, and you're not in the room where the decision gets made. So, you know, there may even be two different departments and they have two different analytics trackers, and they're both getting downloaded and it's slowing down your website. And that's a real problem. So, you've got multiple ad networks. You've just got a lot of different sharing tools. So, one of the things I've been working on is AMP, Accelerated Mobile Pages. And so what this does is it resets things. It's a spec. It was initially set up by Google, but it's an open source project. Lots of people have been contributing to it. And it sets down some ground rules where it sets up some sandboxes where only certain things are allowed to happen in your page. And so if you can still have tracking, you can still have ads, but they're sandboxed away where they're not going to slow down your website. So I'm pretty excited about that because it's a way to demonstrate to people, hey, here's how your website could work if we kind of sandbox these third-party things and stop them from slowing down our website. And I think it's worth trying because not only does it provide a fast experience on mobile if you get it working, you can use our Drupal AMP and theme modules to help make that happen. WordPress has their own AMP stuff as well. But then you can go and say, hey, look, we're getting a lot more engagement because we have locked this down a lot more. Could we do this with our regular website? We're seeing real improvements. And I think that could help change the culture by sort of setting some ground rules as to how this stuff works. So All right, I'm going to turn it back to Steve for some final thoughts.
Sure. So Conway's Law is an old computer science law. Organizations designing systems are going to reproduce themselves in these systems they create. For Drupal and WordPress teams, you can think of this as it relates to server-side and client-side, as we've been talking about today. If a team has a very clear division between the developers working server-side and the developers working client-side, there's a really good chance that the website they've built will have a very clear line as well. Going back to the beginnings of Drupal and WordPress, those communities didn't have a particularly sharp line between back-end and front-end. And as a result of that, if you look at the internals of Drupal or WordPress, there's a very blurry line, or what some people call a very permeable layer between back-end and front-end. And that's not necessarily good or bad. It's just a manifestation of the organization of people in the systems they build. Mark, if you could go to the next slide, we can talk about some of the ways this is negative. And we've got, just go ahead and advance to the 5 points here. If we have factions in our front end, in our group of front-end developers ignoring one another, there's a good chance we might be loading 2 or 3 or 4 copies of jQuery that ignore one another. At a recent WordPress conference, I was hearing about a really prominent site where they literally were loading multiple copies of jQuery because each one was getting used by a different element of the site controlled by a different group of people. That's a problem amongst people that manifests itself in the website itself. And Mark, let's go to the next slide and wrap things up a bit. We're moving in the right direction as web developers when we can describe how our site is built. So Mark was just highlighting the importance of understanding how the browser actually paints things, because you can have the same sets of assets and progressively load things in a way that gives your users visual feedback indicating that the page is getting loaded, or you can wait 1 second, 2 seconds, 3 seconds, and have everything flash in at the last millisecond. Understanding how the browser puts the site together will give you the power to make that site faster, much more so than just focusing on all the metrics involved in trying to make them smaller. Having a clear mental model of how the site is built will really help. Also, having the ability to track changes over time with a tool like New Relic or some other performance monitoring tool will then allow you to estimate the future impact. So when your stakeholder says we want to add a third image carousel to our homepage, you can point at historical data and say, here's what happened when we added the first and second carousels. Our site got this much slower. Let's now have a conversation with more information. Having that information will then give you the power to start new projects with performance limits in mind. And ultimately, if you can make decisions that make your site faster and your team faster. Mark, I think we've got one final bullet here. As exciting as some of these topics are, a lot of them are old, boring topics, and that's okay. We don't need to get super excited about security issues. We don't need to get super excited about the details of HTML. A lot of web development practices are long-standing, and the optimization of sites can be handled in a way that would be recognizable to someone building sites 10 years ago, 20 years ago. So Atusa, I think we've got about 10 minutes here left for questions. Have any come in through the webinar?
Yes, we do. All right, we'll try and get through as many of these as we can. Anything we don't get through, if you really want the answer, please feel free to email us and we'll make sure you get that. The first question is, Steve, I believe this was in the beginning, so it's for you. With the Pantheon platform, will I need to use those plugins concerned with page speed still?
So there are some plugins in the WordPress community that will do full page caching inside of WordPress. And if you're on Pantheon, then you have Varnish, a reverse proxy cache outside of WordPress itself, doing that task of full page caching. So a lot of the WordPress plugins that do full page caching inside of WordPress, often using the database, aren't necessary.
Right. The next question, I'm going to give you a two-parter. I think this one is for Mark. The first part is, Mark, you said BEM CSS systems. What is that acronym? And then the second part is, am I understanding H2 accurately? You don't need to minify JS/CSS in H2, which was necessary in H1.
Sure. So BEM is block element modifier. It's basically a syntax you can use to write your classes, and it's a way of avoiding chaining together multiple CSS selectors, which can lead to a lot of specificity problems and makes it difficult to make changes to your CSS because it just becomes this spiral of specificity, and you get more and more CSS rules, and it's hard to change things. And BEM helps to solve that. So it's a really good technology to look into. H2, so there's two different issues. One is you overall for performance, there's two big things you want to think about. One is reducing the amount of file size transfer that's happening, and two is doing less things. So H2 helps with the doing less things sort of thing. It's doing less of the server in the browser figuring things out for every single connection. But file size still matters. So minification is the process of sucking out all the extra space and often like replacing variable names with something that's like 1 or 2 letters if you have a bunch of CSS or JavaScript, and it still all works in the browser, but it's a lot. It reduces the file size. That's still a good thing to do with H2 because file size still matters.
Alrighty. Steve, I believe this one was during your portion of the presentation. The question is, what are the optimal cache settings for minimum cache lifetime and expiration of cache pages in Drupal 7 that works best with the varnish provided by Pantheon?
So I think it really depends on your content, especially in Drupal 7. One trade-off that sites have to get into is, say, the home page. So often stakeholders will have an expectation that the home page shows the newest content as soon as that content is saved. And in Drupal 7, it's harder to know all the places where a piece of content is used. In Drupal 8, if you've got node 1, 2, 3, you can rely on Drupal 8's improved cached metadata system to clear all of the elements and all the pages that rely on node 1, 2, 3 anytime node 1, 2, 3 saves. In Drupal 7, that ability really isn't there in quite so robust a way. So what a lot of sites will do is every time a piece of content is saved, flush all of their caches, which is not a great system because you're then losing that that benefit that comes from caching. So I think a lot of sites just split the difference and set cache lifetimes of a few minutes. For a highly trafficked page like the home page, it's important to remember that moving a cache between 1 minute and 5 minutes isn't going to affect your cache hit ratio all that much, because if your homepage is getting a ton of traffic, then the vast majority of the traffic is going to hit varnish no matter what. Yes, someone will reset the cache every 1 minute or every 5 minutes or every 15 minutes, whatever it is, but everybody else is getting a cache. So your cache hit ratio isn't changing all that much in that case. Tuz, I think I'm mostly rambling at this point, but feel free to come to agency office hours, which are in just a couple hours, 4 p.m. Central today, if you want to talk about cache lifetimes more.
All right, I'll squeeze another few questions in there. Next one is, Mark, I think this is for you. If using a CDN and Drupal allows for user-uploaded files, how does a CDN know about those files? Is there typically a Drupal module for uploads plus in CDN?
I'm going to let Steve take that one.
That might be for you.
Yeah, I mean, I think the short answer is it varies depending on which CDN you're using and which which modules do you use. I think basically some CDNs will rely on subdomains, and particularly in an HTTP1 world, there was a strategy out there for a while of having static assets be served multiple subdomains, because some browsers would limit the number of connections per domain. So you could just point like subdomains A through Z at your site as well. Those subdomains would be controlled by the CDN, but they're still pointed at the same server. So they then actually get into the CDN by someone's browser hitting, say, a.pantheon.io. If the CDN doesn't have the file distributed throughout its global network, it would then go to the origin server, Pantheon.io's infrastructure itself, get it there, and then propagate it out around the world.
All right,
I'll just mention that having multiple subdomains, so fragmenting your domain, is a pattern that's really only relevant for H1. Doing that in H2 is actually an anti-pattern, because for each of the subdomains, your server and browser have to have that awkward conversation. And so if you can reduce the number of awkward conversations, like, that's just a good thing in life.
Yeah, it's interesting how HTTP2 is just flipping completely a lot of performance recommendations.
The whole new world.
All right, guys, I'll get 2 more questions in here.
Right.
Next one, Steve, this is for you. So as Pantheon is a reverse proxy server, does it handle DDoS attacks and load balancing well?
Yeah, so Pantheon, we do have our own load balancing built in. So for higher level plans on Pantheon, Varnish is at the edge layer, and then Varnish will route requests to however many PHP containers you have. So at the business plan and above on Pantheon, you're going to have more than one PHP container. Some of our elite sites will have a dozen or more PHP containers. So the load balancing does happen at that Varnish level, and we also have some DDoS protection for everyone on the platform as well. I think for really high traffic sites, they're also relying on their CDN, be it Fastly or Cloudflare, Akamai, whichever they're using to provide additional DDoS protection.
All right, I'm going to end this with a question from Mark, and that is, which CDN do you recommend for the TLS latency issue with HTTPS?
I don't have a particular CDN to recommend that does that better than others. General CDNs are designed to work with that. So that's the entire. I don't know of differences between the two. So maybe Steve knows more about the differences between the different CDNs.
Not from a performance standpoint. I use Cloudflare as well, marked my personal site for that same reason of the free HTTPS plan.
Alrighty. Unfortunately, that's all the time we have for today. As Steve mentioned, we are hosting agency office hours if you didn't get any questions answered, or you could always email those to us as well. Thank you all so much for watching. If you have any additional feedback, please visit our website where you'll find a contact us page, and we'll put you in touch with the best member of our team. Have a great week, everyone.